Hello, and welcome to Computer Tech and More. Today we're going to be taking a look at the Arctic P12 Max. Let's jump right into the graphs and then we'll do our open box experience. Alright, before we get into the graphs and the data, this is the raw spec information based off the manufacturer's website that I could easily gather for it. So it is pretty much a bog standard 120mm fan with a 25mm thickness. Fluid dynamic bearing, 12 volt, 0.29 amps. So you are getting pretty close to not being able to have two fans on one header with this amperage. Airspeed is 200 to 330, no, not 300, 3,300. Airflow is 81 CFM. Static pressures are at 4.35. Wow! And noise level at 20.63 decibels. And note that every manufacturer may measure decibels differently, so you can't always directly compare them against each other. And warranty is 6 years. Okay, first up in the testing graphs, we have my case simulation test. The case simulation test can be looked at in a couple different ways. The first way is by blowing in air. So the most perfect fan in the world would have a perfectly flat line. So in my opinion, that means that the fan would have, as the air gets blown out the back, would have a perfectly cylinder shape in the exact size of the fan that it's simulating. So it'd just be a cylinder of air going directly at it, and it would have no losses whatsoever. But we don't live in that kind of ideal world. Instead, we live in the real world, and there's air that the fan is pushing out of its way to get the air that it's sucking in to the back of the case. So that means we're going to see losses. But what kind of losses are we going to see? Well, then the best fans are going to have as little loss as possible and as linear as possible. You don't want to see a fan that just drops off and goes to zero. That would indicate that the fan is shooting air off to the sides rather than pushing the air towards the back of the case. It is just something that you want to avoid in a fan, that it just has a steep drop off in performance. So what can we say about the testing from the other perspective? Well, this test also simulates different size cases. So I took it at 4 data points: 6 inches, 9 inches, 11 inches, and 14.5 inches. Each of those data points is representative of a different size case. So 6 inches is representative of a small form factor that still requires a good amount of airflow. I don't know one specifically. I don't actually build in small form factor, but something that still requires a solid amount of airflow going through it, as opposed to ultra compact ones that try to squeeze everything into a very tight amount of space. While 9 inches is representative of a very compact tower that still has a front to back airflow. 11 inches is representative of a standard mid tower, something like the Meshify 2C or Fractal Design or Corsair 550D. And 14.5 inches is representative of like the Fractal Design Torrent, where it's just a big case. And ideally, especially if you're using an air cooler, radiators don't matter as much, but if you're using an air cooler, you want the air speed at whatever size case you have to be as high as possible. So let's say you have a compact case, the 9-inch size. You will be looking at which fans produce the most amount of airflow at that 9-inch mark. If you've got 11-inch case, or a mid-tower case, so you're looking at that 11-inch mark, you want the highest amount of airspeed there. And the reason for that is having a higher airspeed hitting the fan that is basically cooling off your CPU means that it doesn't have to work as hard to suck in the air. It just keeps the momentum of the air traveling through it, and also means that there isn't as much heat buildup around the cooler, so it allows it to operate more efficiently. None of this means anything unless we can compare it against something. So I've noise normalized distance from the fan versus airspeed. My noise normalized value is based on 40 decibels by having the fan or the microphone base basically right up against the fan blades. I have future testing methodology video that I'm working on retesting every single fan using a new testing methodology that I'm hoping will reduce the amount of error from plus or minus 4 decibels to plus or minus 2 decibels, and reduce the amount of error in how close I have the microphone to the fans, causing extra air turbulence of air coming into it that's causing buffering effects on it. I think I was getting some of that and was causing some fans to give me falsely high noise levels. But it's hard to say for certain until I finish testing every other fan and then organizing the data. So I hope you stay tuned for future content. But let's talk about what we're looking at right here. This is noise normalized. I think I mentioned that already. And that noise normalized value for the control fan is based off of the A12X25 running through my old case, or in my old case, the Corsair 550D, running through an AIO. So that would be 2 fans running through the AIO. And I found that 1,200 RPM to be particularly silent. So when I set it up for noise testing, I used that RPM as the baseline for whatever noise level I got for it. So it just turned out to be around 40 decibels. So that's what I ended up using. So that's the control line. That blue line on this graph is control. The P12 Max is the red line and the P12 is the green line. So it's pretty interesting that the P12 Max is actually more efficient, better at moving air than the P12, except when you're looking at big cases. The P12 appears to outperform it by a little bit, but both of them are worse than my control fan. So again, you would use the data point that's applicable to your size case. Next, how do they do at 100% PWM fan signaling? Well, the P12 and my control fan are near and identical. Do note the RPM and the noise level that they're running at in the legend on the side, while the P12 Max turned out to be quieter than the P12. I may have just gotten a lemon, but who knows? Or maybe I got a golden sample of the P12 Max. But it was running at 3,485 RPM, so it's a lot higher RPM than P12. It was making less noise, so I may have gotten a golden sample there, like I said. But it is vastly outperforming both my control and the P12 regular, but it's also spinning a whole lot faster than the control fan, which is based around a 2,100 RPM fan, so it's hard to directly compare them. But let's say you want to say, how do we compare it against every other fan you've tested? Well, this isn't every fan because it would be impossible to read the graph, but it shows a lot of different fans, and specifically fans that I put into kind of categories. So up at the top you have the best fans, at the bottom you have the worst fans, and somewhere in the middle is somewhere in the middle. And it's pretty clear that the P12 Max is a better fan, unless you're looking at a big case, where it tends to drop off a little bit too quickly, in my opinion. But it is better than several other fans. Like this blue line is representative of the P12 ARGB. The Max version is outperforming it for the same amount of noise in the current testing methodology. So if you're looking at kind of those two, well, you might as well go with the Max. Bumping things up to 100% PWM fan signaling, and the P12 Max is right at the top. Again, we have the legend over here where it has the fan name, the RPM, and the noise level it was, well, running at during this test. So the P12 Max was spinning at 3,485 RPM and 60 decibels. The fan that is right underneath it is the Silent Wings 4 Pro 140 millimeter fan, doing 61.5 decibels of noise. The closest 120 millimeter fan is right here, and this is the Silent Wings 4 Pro 120, spinning at 2,930 and producing 53.4 decibels. So it's pretty clear that the P12 Max isn't as noise efficient as the Silent Wings 4 Pro, but it is producing actually better performance. It is up to you to decide if that extra performance is worth the noise. I cannot make that decision for you. And we have the other Arctic fans highlighted as well. Next up, we're still onto the case airflow test. And in this one, we're taking a look at the 9-inch mark of airspeed versus decibels. So 9-inch mark is where I tended to see the separation between the fans that were doing really well at the 6-inch mark and fans that didn't create good airflow. So fans that tend to shoot out off to the side still tend to do pretty well at the 6-inch mark, but they drop off quite a bit at the 9-inch mark before completely tanking at 11 inches. So I ended up using the 9-inch mark as sort of this middle ground between it to do kind of the noise versus airspeed. So in this graph, better fans are going to be sitting in the top left category, worse fans are going to be sitting in the bottom right. And we can see that the P12 Max is sort of in the middle. It's actually upper middle, so I'd say it's doing pretty darn good. Arctic P12 Max. Arctic P12 cold configuration. Next up, we're seeing how the fan performs going through my CPU air cooler. My particular cooler is the Noctua U12A that features two Noctua A12X25s. However, in testing, I only use one fan on it to achieve all the performance data. So that would be meters per second on the vertical and RPM on the horizontal, or noise on the horizontal and airspeed on the vertical, so that everything is consistent and as apples to apples as we can get it. So the left graph here is RPM versus airspeed, and that is basically a blade efficiency test. It is how good is this particular design at pushing air through the seatsink. And we can pretty much see that the P12, the P12 Max, and my control fan all line up very closely. Actually, the P12 Max and P12 outperform it by a little bit as RPM increases. And interestingly, the P12 actually is slightly better than the Max until it reaches its maximum, and then it gets blown away by the P12 Max. When we jump to the right graph, we're taking a look at noise versus airspeed. And this is how much air can this fan move for a given noise value. So it's a noise efficiency graph. And here we can pretty much clearly see that the P12 regular edition is not so great, while the P12 Max is following my control line spot on, and it's doing really well. It's looking really good. Now we're on to comparing these fans against one another. So I've already talked about the error in my measurement for my current microphone testing of plus or minus 4 decibels, and hoping in future videos to reduce it to 2 through an update in the whole testing methodology. But there's also an error in measurements in my anemometer. So I have an off-the-shelf anemometer, and its accuracy is plus or minus 0.1 meters per second. So that means that like the Bionics P120 and the P12 ARGB could be considered functionally equivalent because they're within 0.1 meter per second of each other. Kind of like the P12 is technically within 0.1 meters per second of the Bionics P ARGB. But I do each of my tests 3 times and I get an average result. And my average result dictates where these fans are placed. And on average, this is where the fans place. So I can definitively say that my data is accurate and that these fans rank in this order for the current way of testing the fans. Other notes about this. Right here on this legend right there, there's a number like 250 W, that's 250 watts equals 3. That is 3 meters per second. So in another video, I actually went and did full testing on my Noctua U12A cooler to determine what airspeed was associated with what wattage. And the only variable in that test was actually adjusting airspeed, because I just let my CPU run at whatever its maximum temperature it would achieve, and I have an Intel i7 11700K, so it was running at 91 degrees C. So it was rip-roaring hot during this test, and I just let the fans run to try to cool it, and it achieved a stable wattage, and then the wattage is equated to a clock speed. And Airspeed traveling through a heatsink or radiator is very similar in the way of diminishing returns as clock speed is to wattage. So at some point, you can keep pumping more and more watts into a CPU, but you're not going to get very much increase in clock speed out of it. In the same way that you can push more and more air through your heatsink or radiator, and at some point you're going to see very little difference in how much extra cooling you get out of it. Mind, there are differences. So looser fin stacks, so ones that have larger separations between the fins, or radiators for AIOs or custom loops that have wider, looser spacings in that fins so air travels more easily through it, we'll see a much steeper diminishing return for how much air can go through it, meaning that a higher airspeed going through it, so how these fans rank, we'll see less heat dissipation than something that has a much tighter fin stack and or tighter fin spacing. There'll just be more heat to carry away. And this is kind of related to how good is the fan at pressure optimization. So if a fan is not very well pressure optimized, it's going to have a much harder time pushing the air through the heatsink. So you're actually going to get lower airspeed going through it than one that has wider spacings, where it's going to be a higher airspeed through it. Woohoo! Education! Learning about computer stuff. All right, let's focus in on how this fan ranks. So the P12 Max in my noise normalized testing is doing really quite well. It is only a touch below the Noctua A12X25. For the same noise level, it's achieving 1.2 meters per second of airflow. But how could you get better performance? Well, you would pick a better fan, I guess. So like the Ventro Pro is the same as the Gentle Typhoon. And for that, you would get more air speed for the same noise value. So this relates to how else can you use this data? Well, you can use it if you don't have the same CPU as me and you don't have the same cooler as me. Well, you can still apply some certain logic to it. So let's say you had the TLG12. It's moving 0.6 meters per second of airflow. If you upgrade to the P12 Max, you're now moving 1.2. You've doubled your airspeed. So you can either take that and run with it because you found the noise level to be very acceptable, and now the CPU can draw more wattage, so you get higher clock speed for the same level of noise. Or let's say you don't have an unlocked CPU, you're now running your CPU cooler at the same noise. Or you can take that and dial back the fan speed a little bit, so now it's running quieter because you think my particular noise level is too noisy, and you're going to get the same level of cooling for less noise. That's how you can use this data. Moving things up to 100% PWM fan signaling, everything is more or less the same in terms of the wattages and how everything relates. My CPU's maximum wattage is 250 watts, so everything above that is just arbitrary. And the P12 Max is a top contender. It is moving nearly as much air as like the T30 and the NFF12 3000 RPM fans, but it is doing it at very kind of acceptable noise levels. So it's just like 60 decibels, basically. It is equivalent to the T30 in terms of its noise value and only sacrifices 0.1 meters per second of airflow for a standard thickness fan. The T30 is 30 millimeters thick. And the NFF12 is just significantly noisier at 69 decibels. Ouch! The P12 Max completely blows the other Arctic fans out of the water in terms of its airspeed, and completely blows away the NF A12X25 in terms of its performance. However, it is doing it at the price of more noise. So this is where you need to decide what is important to you, having the absolute maximum performance or having acceptable noise levels. I cannot make decisions for you, I just can only present the data. Next, we're taking a look at the data from airspeed through the cooler versus noise level. And I've highlighted the P12 Max in green, and you can see that it is in the upper fan category, I would say, but not in the best fan category. The best fans right now, in my opinion, are like the Gentle Typhoon and the Mobius OC, and of course the current testing methodology. The P12 Max is performing very similarly to the Silentwings 4 Pro 120, where they follow this sort of trend line in the middle. So I put that into the very good category, but not quite the extreme best, and it's outperforming what I consider the bad category. The next graphs are CFM. So CFM I don't really particularly like as a test because it's very scientific. You'd use it to generate PQ curves and other scientific type information, but it's not really realistic in case airflow applications. So in essence, CFM is putting the fan, placing it so that the air blows down a tube, and then you're measuring the airspeed at the end of the tube. What this does is that a fan that shoots air off to the sides rather than straight down, well, because it's in the tube, the air still is going to want to naturally go down the tube. So it'll hide the fact that the fan is shooting air off to the sides rather than straight down. So two fans, where one shoots air off to the sides and one that's good at shooting it straight down, they're going to look closer in performance than they actually are. But CFM testing is good at indicating kind of one thing, where it's similar to it. It's similar to how air travels through a radiator or heatsink or AIO or something like that. Because an AIO, heatsink, radiator, whatever you're using them up against, will naturally straighten the air as it flows through it. So in the same way that calculating CFM airflow, the air is traveling down the tube and is having a very similar effect on it. So basically, all that said, how does it rank? Well, how does it look? It looks very similar to how it did through the heatsink in my air cooler. And we do see a little bit of difference in the noise versus CFM, where the P12 Max looks a little bit worse than it did in the heatsink test. Comparing against every other, well, a majority of fans that I've tested, well, I had an error in my presentation, so I had to go back into my Excel to pull it up. So I do apologize for that. I've highlighted the P12, and I'm actually having errors in Excel where I can't edit my graph. So in the end, it's going to look very difficult to read, but here's the P12 Max, and it's functionally kind of in the upper middle in noise normalized testing. It's actually doing pretty well overall, and you can see like the Ventral Pro is up there, which is the same as the Gentle Typhoon, the Mobius ARGB, and not everything is lined up. I'm sorry about that. There's just too much data on these graphs, and it's only highlighting what it wants. So now I'm highlighting the Ventral Pro, now the Mobius OC. This one is the AF120 Elite. Next at 100% PWM fan signaling. Again, I apologize for the errors going on in this, but right here is the P12 Max. Let's see, above it is the T30. Below it is the Iceberg Thermal Extra. Let's see, those are all 3000 RPM fans. Then we have the NF F12 3000. What's next? Mobius OC 120. I know that this is not ideal. Then the Silentwings 4 Pro 120. So it's pretty clear that the P12 Max is a very good performer. And this is actually the graph that I ended up with and having problems with because it doesn't list all the data that I want on it. Luckily, this next graph does, so I can continue with my regularly scheduled program. So in purple, we have the P12 Max, and it's following this line right here. So it's doing remarkably well overall, I would say, versus the other Arctic fans kind of grouped down at the bottom. So the P12 Max is once again proving to perform quite well. Let's jump to our open box experience and examine this fan itself. Okay, so a little bit of talking voice conclusion. So what do I think of the Arctic P12? I think it's an excellent choice. I think it's a great all-rounder if you are looking specifically at 120 millimeter size fans. That being said, there are better choices for case fans going up to 140 millimeter fans. They tend to do better in case airflow applications. But if you want to fill out 3 fan slots on the front of your case, this certainly would be a great choice if you're looking at putting in 3 fan slots. on your radiator, whether it's AIO or custom loop, it is still a very excellent choice. So it's becoming a very good all-rounder for a budget option, but if you're looking for noise performance, I'm finding it to be a little on the noisy side. So now with all that said, I do want to thank each and every one of you for watching my video here on Computer Tech and More. Please subscribe for more content. Check out my Patreon page. It's viewers like you that really help make all this channel possible. I want to acquire a better testing microphone. Right now I'm just using the one that I'm using to record my voice on for all of you as my recording mic for sound testing. It's not the best for it. It's just a little outside my budget, and I want to be able to acquire a test system so I can do all my hardware testing on one dedicated system rather than using my gaming PC for it. But it's only with help from viewers like you that I can make that possible. And now let's jump to the raw data. And please check out my Patreon page. It's viewers like you that help make this channel possible. And have a great day. I'll see you all next time. So now that we finished going over the data, let's do our open box experience and do an analysis of why I think the fan performs the way it does. So first it comes in this basic box. It's got a 0 RPM mode at less than 5% PWM. It's the P12 Max, 6-year warranty. The back of it, very basic information, little QR box. It's got the static pressure and other spec information. Inside the box, it comes with some screws, pretty standard, but not much else. So let's dive right into the fan. So at first glance, this looks near on identical to a regular P12, except there's one fundamental difference about this fan versus the regular P12. It has a shrouded fan. So that means that there is an outer ring right here that the fan blades connect to. Now, you may be wondering why this part is important. Well, the distance between the edge of the fan and the housing determines how well the fan performs. So if there's a 0 distance, then it'll perform at its best in terms of how the air flows through it. Because getting a fan to have the minimum amount of distance to the outer frame is very hard. Of course, the disadvantage of having this outer shroud is weight. You've now added a substantial amount of material around the outside of the fan, so you need a much more powerful motor to drive the fan at the same and even higher RPM. And that's what Arctic has done. They beefed up the motor from the regular P12 to this. They've actually increased the size of this hub to house that larger, more powerful motor. Now I want to focus in about the frame just for a second. So the regular P12 doesn't have any rubber pads on it. The P12 Max, they installed some rubber pads. That helps with vibration transmission into your case by the fan. Now ideally the fan motor creates no vibrations and the blades are perfectly balanced, but inevitably it's hard to get that absolutely perfectly aligned or perfectly balanced. So having some rubber pads on it just helps absorb a little bit of those vibrations. But again, you don't want it to be too badly, otherwise you're going to be transmitting a lot into your case. Both bad for noise, and if you're using it with mechanical hard drives, the life of those hard drives, as it'll cause vibrations. Looking at the back, it's got some nice beefy, fairly thin struts. The power cable runs very tightly along this edge, so it's very thin so that very little air gets stopped by this post. So allowing more air to travel through it and, well, reducing that blockage, so again, higher airflow. The frame itself is very square, which is good for pressure applications. So if you have one of these on a AIO that you get in like a pre-built, they often have like a single fan AIO, it'll create a nice seal. And if you have several of them stacked together, so 2, 3, they'll all stack together fairly nicely to create a nice pressure seal to have high performance going through your radiator or heatsink. In heatsink applications, that pressure seal is a little bit less important because heatsinks tend to have higher airflow than a radiator. So just the thin density is what I'm talking about. And this performed overall fairly well and was quiet and had good performance per RPM. So that's got to do with the blade design. And in its case airflow test, it was good all around as well, which means that this blade design is well optimized for both airflow and pressure, which is basically like the golden ratio in PC fans. Can you make a fan that is good at basically everything? So that's all a person needs. So it means a person is buying 3, 4, 5 of one of your fans as opposed to buying this brand and that brand to fill out their case to get the characteristics that they need. So basically, when looking at these fan blades, they look very similar to the P12, which performed very well in my testing, although was noisy in comparison to other fans, but it had good performance characteristics. So the improvements that they did to the motor really helped with that noise profile of this fan. And they may have also done some little tweaks to the blades themselves. And again, with this ring housing, means that all the fan pressure is being pushed through it, and there's no room for it to really seep around the edges. Now, in theory, some air could be seeped around the edge of the ring, but that is a lot less likely than just around the blade itself. So it creates this nice force push for those radiator applications. The blade design themselves is this sort of arc shape. So for pressure applications, you want a blade that's flat. For airflow applications, you want a blade that's more or less vertical, forcing in and out of the camera. And hybrid ones are basically a curved shape. And how much of a curve depends on the brands. So the different curvatures allow for different overall characteristics. A steeper curve will sort of accelerate air down it and help sort of push the air down. A flatter curve is going to could potentially generate higher static pressure, but not accelerate the air as much for airflow. So it's really a balancing act in regard to that. So the curvature on the blades is actually steeper on the inside and then a little bit shallower on the outside, with the leading edge having this fairly sharp cut on it. And that's just to help slice through the air basically, and then channel it down into the curvature. And one nice thing about this is if you stick your finger in there, it's less likely to get cut at the very sharp tip, because there isn't a sharp tip, but it could still hurt. So overall, I think Arctic has really done a great thing with this fan. It looks excellent and performs well. Let's jump to the value proposition to see how it rates with the other fans for how much it costs. Now we are in the value proposition. This is how much air can the fan move per how much money does it cost. So the P12 Max costs $12. Mind, I've seen it on sale for as low as $8.99. So that would give a giant boost to its relative cost to performance, probably making it actually the absolute best I've ever tested. But I'm reviewing it at its base price of $12. And here we do see, so this is the case airflow test, 6-inch mark, noise normalized, 100%. It's ranking quite towards the top. Not the absolute best, but towards the top. So what does this mean for you, the buyer? Well, if you're on a very tight budget, as in every penny that you can save on building your computer is key, you go for these graphs 100%. You want the absolute best fan you can get for the least amount of money. If you've got a little bit of extra money and you want better noise performance, or you're looking at RGB and you want the best value for RGB, so best performance per dollar with an RGB fan, or best performance per dollar for a quiet fan, you'd use this data in conjunction with the earlier data and determine which fan application is best for you. And if you've got unlimited budget, well, then you just choose whichever fan you want and ignore me altogether. But looking at the fan at 100% PWM fan singly, it is like the second best one we're looking at. Moving things up to the 11-inch mark. So this is where the better fans that are good at creating a good concentrated airflow will push ahead of the fans that really are not good at creating a good concentrated airflow. So like the T30 does very bad in case airflow tests. And the P12 Redux, despite being a cheap fan, doesn't do very well in this test because it just doesn't have a good concentrated airflow. And neither does the NFF12 3000, despite pushing out tons and tons of air and being relatively affordable. It's just not good in case airflow testing. So the P12 Max is actually the best one at 100%, but if you're running your case fan at 100%, something is terribly overheating. And you may want to rethink about what fans you are using or what coolers are in your case, or something else is going on with it. Jumping to performance per dollar in the CPU cooler. And we can clearly see that the P12 Max is a top contender in this category. The Antec Storms are triple packs, so if you're actually filling out an AA or radiator, they may be the better choice overall to save a penny. But if you're looking at raw performance, the P12 Max just kicks butt. It blows everything else away at 100%. At my noise normalized value, it is still a very high contender. And in CFM, well, it's a very similar story to what we previously saw. But now it's not quite as high, but it's effectively in the same spot. And 100%, it's just the best. Well, that's the show. Thank you very much for watching my video. Please subscribe for more content and check out my YouTube page. I have lots of fan videos out up there. And if you have any fans in particular that you want me to test, please leave it in the comments down below because I'd love to take a look at what you all want to see. Okay, right here is the raw data for the P12 Max. You can record it down for your own purposes, meaning you can put it into Excel, type it out, and create your own custom graphs if you want. But if you're going to use my data for your, a publication, whether it's a video or a document or anything like that, I do ask that you reference me and my channel because I'm the one who generated this raw data. It's a lot of work doing fan testing. It takes a lot of time, like 2 hours per fan, almost. And it does take time to update graphs, create charts, write a script, and of course do all the recordings. So thank you very much for referencing me if you do use it. And well, hope you have a great day, and I hope to see you next time here on Computer Tech and More. And also, if you have any fans you want me to test in the future, please leave it in the comment section down below. Almost forgot. Anyways, thank you. Bye-bye. Before we get into the charts, here's the basic spec information that I could find on the manufacturer's website for Corsair. It's pretty much a bog standard 120mm fan. Uses their hydraulic bearing type. 12 volts, 0.3 amps, 400 to 1500 RPM. Airflow is rated at 47.73 CFM. Static pressure is 1.46, which is a bit on the low side. And noise level is rated at 22.6 decibels with a 2-year warranty.